Hello everyone, hope you all are doing well. So today we will start our new topic named as composition of vector and rectangular components. First of all, we should know the definition of composition of vector. As the word composition means the composed of. So the definition is a vector is reconstituted, 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 or you can say reform from its components from its components is called composition of vector. Let's move further with a diagram of composition of vector, that how to its components that reconstruct or reform and makes the vector that is called the composition of vector. So let's move forward with the diagram. Like we are having diagram over here. Like from this one point, this is a point from and this is a triangle. Like in lastly we have done the resolution of vector. We have make this kind of triangle. This is the B point, this is O, and this is C. Okay, this is called AX, it is base. This is called AY, it's perpendicular, and these both components combine together and form the hypotenuse. So this formation is called the composition of vector. Hope you understood this one. Okay, composition of a vector based on its magnitude. This is its magnitude. Direction is equal to its magnitude. Its magnitude. How we can find the magnitude? So let's first derive the formula of magnitude. Magnitude. Okay, so we will find the formula of magnitude according to Pythagoras theorem. According to PGT, Pythagoras theorem. Okay, Pythagoras theorem, what we are having, that we are having h square is equal to b square plus p square. Hypotenuse is equal to base plus perpendicular. So this is the definition of composition of vector, that when two components combine together reform a new thing that's called hypotenuse, or you can say the combination of two components and form another thing is called composition of vector. After that, what we were having, let's just wait for it. Like in this was the diagram over here. Okay, hypotenuse we are having O to B, and we are having C over here. Okay, this is the hypotenuse we are having O to B, base we are having O to C, and perpendicular we are having B to C. B to C we are having AY, O to C we are having AX, and this one we are having magnitude. Okay, so let's move further to derive this one. So hypotenuse square, at the place of hypotenuse square we can write OB square. As I told you that hypotenuse square is equal to OB square, we were over there a line. After that, move to the base. In base we are having O to C we are having base, we will put square over here, plus we are having O to B to C. B to C we are having perpendicular. Okay, in diagram I am writing this all from the diagram that I made earlier. After that, move further. OB is equal to, I said that magnitude, we are having magnitude, so A square. After that is equal to OC comes from A square X, that OB is equal to X, and then add this one, and then we are having A square Y. Let's fix this one confusion, that how this AX and AY came. Like we made this one diagram. In this one we are having this one hypotenuse, this one perpendicular, and this one base. This point is O to B and this is C. Okay, hypotenuse we have O to B and having magnitude A. So hypotenuse is equal to A, we have written over here. After that we are having perpendicular B to C, we are having AY. So we have written it over here the as a place of perpendicular BC, and after BC we write AY, and same in as base OC is equal to A square X. Okay, so let's move further. We will taking radical on both sides. Taking radical on both sides. When we will take a radical on both sides, so what will happen, that in radical we will have A square is equal to, again we have taken radical on both sides, so we will having A square X plus A square, sorry by the way, A square Y. Okay, after that let's move further. A square we can write it like A multiplied by A, again we form A square. After that what we are having A square X plus A square Y. We will write this one same as here written, copy from here and paste over here. After that this one A will came out and we are having magnitude, means square cancel with radical and just one A will remain. So 1A is just the magnitude. So this is a formula to find the magnitude. A is equal to radical A square X plus A square Y. This is the actual formula to find the magnitude of the composition of vector. Hope you understood this one. Let's move further with our next topic. We are having the rectangular, sorry for that, yeah, we are having rectangular components. Yeah, you can also say the rectangular components over here. So in rectangular components, actually what happens, that if two components of a vector which on right angle to each other is called rectangular vector or rectangular component. Okay, if two components of vector which are right angle to each other is called the rectangular components. How we should derive this, how it's possible. So like they said that two components of a vector which are right angle, one component and second component, after it's making the right angle to each other, so this is called the rectangular component. Two components, this one perpendicular one and base one, make a one is right angle to each other, so this is called the rectangular component. So after that the question arrived that how we know that this right angle is equal to, means this angle is equal to, we don't know that what the angle is equal to. So as I told you that the two components make one, the perpendicular and base both make a right angle to the hypotenuse. So we should know that perpendicular upon base is equal to tan theta, as we already know that. So we will write over here tan, actually I don't have a sign of theta, so I am writing just in this one position tan theta. After that is equal to, we are having perpendicular upon base. Okay, perpendicular upon base. Now let's move further, that now this one tan is multiplying over here. When it will be goes over there, it will be tan inverse, it will be dividing, then we will go take it up one side, so it will be tan inverse. So just theta will remain over here. You can say angle is equal to tan, we're just tan minus 1, then we are having perpendicular upon base. Okay, actually angle is equal to this, the theta is equal to angle, theta is an angle, so angle is equal to tan inverse perpendicular upon base. So in this one position we can find the angle, that what angle is of the right angle. So like, as I will give you one more, that theta, we are having theta over here. We said that theta is equal to tan, then we also said that it's inverse minus 1. After that, perpendicular, as we know that we have done in the rectangular component, now we are doing in composition vector, composition and resolution of vector, we already done that perpendicular is equal to ay, and base is equal to ax. So at the place of perpendicular we write over here ay upon ax. So actually this is a method to find the theta or angle, you can say. So today we have discussed the two main topics that was remaining. Yesterday we have done the resolution of vector, today we have done with the composition of vector, in which we have done with the diagrammatical and mathematical too, with the definition, and same as in rectangular component. Hope you understood this two topics, because these are very easy topics and similar to each others. Thank you so much.